So here we have derived the current equation for MOSFET. Okay, current, how it is flowing in the MOSFET. Saturation region of operation, otherwise current is equal to the linear region and cut-off region. All three we have derived. And if they ask in the exam draw the VI characteristics of MOSFET, then you have to draw for separately for NMOS and PMOS. NMOS is this one. VI characteristics. When we learned the operation of MOSFET, there we have seen. This is for NMOS. Okay. Either the replica will be the PMOS, but it will be third quadrant. First, second, third, fourth. So this is third quadrant. After the PMOS and those are complementary to each other. Okay. So this graph you have to draw. And if they don't ask about the graph, you can leave it. Right. Next we have DC transfer characteristics of CMOS inverter. This is again the important question. DC transfer characteristics of CMOS inverter. So just now we have derived the current equation. In current equation, you need to remember the current equation I is equals to Q by T. And for Q and for T, whatever you need to substitute, those equations will come into picture. Okay. So current flow agati so any terms bartav nodri. Current flows from drain to source. So L bartada, W bartada, width of the MOSFET, length of the MOSFET, mobility, velocity, all these things comes. So some link you have to remember. Sumne yalla back derivation. Understand what terms are required for the current. Q gain back, T gain back, substitutions ಏನೇನು ಮಾಡಬೇಕು ಅದರ ಪ್ರಕಾರ link ಇಟ್ಕೊಂಡು study ಮಾಡಬೇಕು. Okay. Next here we are studying DC transfer characteristics of CMOS inverter. Transfer characteristics means it is V, a graph where we plot V out versus V in. V out versus V in. Wait till I understand. Okay. So here it is a graph of V0 versus Vi. DC transfer characteristics of CMOS inverter. It is a graph of V0 versus Vi. Okay, that we will study how to plot this graph and all. Okay, so first thing, CMOS inverter, we will draw the CMOS inverter. What is CMOS inverter? We know this is CMOS inverter. Okay, here each and every term we will define. Say for example, this is source, this is drain, this is source. So gate also we have. Right. So this is gate. So here we will define few terms which are very important in this part. Say for example, VGS of NMOS. So I call it as VGS. N stands for NMOS. So what is VGS? VG minus VS. What is VG? Say V input voltage is VG. Okay, and here is output or output voltage. VO. Okay. Here I have VDD, here I have ground. Ground or that is nothing but 0. Now VGSM means VGS minus VG minus VS. What is VG? For NMOS. N andre NMOS. VGS P andre for PMOS. For PMOS. Okay. So for NMOS, what is VG? P. That is V. minus. VS ಅಂದ್ರೆ ಏನು? So it is V in. VGS is V in. VGS P ಅಂದ್ರೆ where source of CMOS is connected. ಗೊತ್ತಾಯ್ತು? VDS ಹೇಳ್ರಿ. VD minus VS. ಹೇಳಿ. VD Vout minus N. VDS is this. VDSP. Huh? Understood? These terms you understood? So, to understand the transfer characteristics of CMOS, okay, we are drawing the CMOS inverter. CMOS inverter the transfer characteristics back to. We are drawing the CMOS inverter and we have noted few terms which will be useful to us. So, next we have a table. Looks like so complicated, but it is very easy. Very easy. Okay. The thing here is we need to understand. Then only it is very easy. So NMOS. I am taking both the MOSFETs because I have two MOSFETs in our design. Okay. So NMOS and PMOS. What I am drawing is I am drawing three regions of operation. Cutoff region, linear region, saturation region. Okay. So MOSFET, N MOSFET will be in cutoff region if VGS is less than VT. This thing isn't really transmission gate heruvaga. If VGS is greater than VT, MOSFET is on. I have said it for N MOSFET. If VGS is greater than VT, MOSFET is on. If it is less than VT, MOSFET is off. VGS less than VT, MOSFET is off. Therefore, it is in cutoff region. Okay, linear region, VGS greater than VT, MOSFET is on. Therefore, I am writing VGS greater than VT. Saturation andre MOSFET is on. MOSFET is on. Therefore, I am writing VGS greater than VT. But I am writing for NMOS. Therefore, everywhere I am writing N. VGS N less than VT N. VT N is the threshold. Threshold what is the NMOS? VGS N greater than VT N. VGS N greater than VT N. Okay. Which is the next in money. Those terms I have substituted here. VGS N ಅಂದ್ರೆ ಏನು? V in less than VTN. So I am writing in terms of V in and V out. Okay. V in less than VTN. MOSFET is off. Therefore output ಏನು ಇರಂಗಿಲ್ಲ. MOSFET ಚಾಲು ಆಗಿಲ್ಲ. MOSFET is off. Therefore no output. Okay. So I am not writing here output equation. ಇದೆಲ್ಲ ನೋಡಕ್ ಹೋಗ್ಬೇಡ್ರಿ, ಏನು ನೋಡ್ಬೇಡ್ರಿ. Okay. Now here, VGS greater than VT. What is VGS? For N. Again V in greater than VTN. Okay. Fine. VDS less than VGS minus VT. These are simply just noted now. Just now we had seen in the previous topic. The point is the VDS. This VDS ಇರ್ತದ ನೆನಪಿಟ್ಕೊಳ್ಳೋದು ಬೇಕಾಗಿಲ್ಲ. ನಿಮ್ಗೆ ನೋಡಿ ಗ್ರಾಫ್ ID ವರ್ಸಸ್ VD ಹಾಕ್ತೀವಿ ನಾವು. ID ವರ್ಸಸ್ VD. So ಇದು VDS ಇಟ್ಟಿದ್ದು. ಹೌದಾ? VDS I am increasing when VDS crosses increase ಮಾಡ್ತಾ when VDS crosses VGS minus VT. It is in which region? ಯಾವ region? Saturation region. ಲೆಸ್ ದೆನ್ ಇದ್ರೆ ಲೀನಿಯರ್ ರೇಂಜ್. VDS less than VGS minus VT. N indicative because NMOS is VDS less than linear region. VGS minus VT. Okay, substitute ಮಾಡಿ. VDS n ಅಂದ್ರೆ ಏನು? VDS n Vout less than VGS n ಯಾವುದು? Vin minus VTN. Okay, critical till greater than ಬರ್ತದೆ. ಇದೆಲ್ಲ greater than. critical. ಈಗ PMOS ಮತ್ತೆ NMOS both are complementary to each other. Both are complementary to each other. Therefore, VGSP ಇಲ್ಲಿ less ಇದ್ರೆ greater ಇರ್ತದೆ. Just put NMOS PMOS ಗೆ. So if it is less here, here it will be greater than VGSP greater than VTP. P ಬರಿಬೇಕು ಇಲ್ಲಿ L ಬರೆಯಲ್ಲ. PMOS ಗೆ ಬರೆಯುತ್ತೆ ನೋಡಿ. PMOS in cutoff region. Okay, this is the condition. VGSP greater than VTP. What is VGSP? ಏನಿದೆ? V minus VDD. But now ಇಲ್ಲಿ V ಅಂತ ಬರೀಬೇಕು LHS ಗೆ. ಸೊ ಈ ಕಡೆ ಮೈನಸ್ ಇದ್ರೆ ಆ ಅಪೋಸಿಟ್ ಸೈಡ್ ಕಳಿಸಿದ್ರೆ ಇಟ್ ಬಿಕಮ್ಸ್ ಇಲ್ಲಿ ಮೈನಸ್ VDD ಇದ್ರೆ ಇಲ್ಲಿ ಕಳಿಸ್ತೀರ ಅಂತ ಪ್ಲಸ್ ಆಗ್ತೈತಿ. ಹೌದಾ? VN greater than VTP plus VDD. VDD ನ ಅಪೋಸಿಟ್ ಸೈಡ್ ಕಳಿಸಿವಿ ಅಷ್ಟೇ. ಇಲ್ಲಿ ನೋಡ್ರಿ ಮತ್ತೆ ಇದು ಗ್ರೇಟರ್ ಟು ಏನಾಗ್ತದೆ? ಲೆಸ್ ದನ್. NMOS PMOS complementary. Greater than ಇದ್ರೆ less than. Okay, VGSP less than VTP. Substitute ಮಾಡಿ. VGSP V minus VDD. minus VDD ಆ ಕಡೆ ಕಳಿಸಿ ಪ್ಲಸ್ ಆಗುತ್ತೆ. Okay, ಈ ಈಕ್ವೇಷನ್ ಇಲ್ಲಿ ಏನಾಗ್ತದೆ? ಲೆಸ್ ದನ್ ಇದ್ರೆ ಗ್ರೇಟರ್ ದನ್ ಆಗ್ಬೇಕು. ಓಕೆ, ಗ್ರೇಟರ್ ದನ್ ಆಗ್ಬೇಕಂದ್ರೆ ಈಗ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ರಿ. VDSP ಅಂದ್ರೆ Vout minus VDD. Vout minus VDD. ಓಕೆ, ಗ್ರೇಟರ್ ದನ್ ಇದೇ ರೀತಿ VGS VGP is VGSP. This is VGSP. Okay. VGSN minus VDN is VGSP minus VDP. So VGSP is V minus VDD. Actually, below minus VDD is below minus VDD. We have to cancel out top. Vout minus VDD. V minus VDD. ಎರಡು VDD cancel ಆಗ್ತಾವ. minus VDP ಉಳಿತು. ಕರೆಕ್ಟಾ? ಇದು ಹಂಗೆ ಇಲ್ಲಿ ಗ್ರೇಟರ್ ದನ್ ಇದ್ರೆ ಲೆಸ್ ದನ್. ಓಕೆ, ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಆಟಮ್ ಪೂರ ಟೇಬಲ್ ಅಂದ್ರೆ ಯಾವ ಮಾಸ್ಪೆಕ್ಟ್ ಯಾವ ರೀಜನ್ ಆಗಿದ್ರೆ ಏನು ಕಂಡೀಷನ್ ಇರ್ತದೆ? V in condition, V out condition. Okay. This table you have to write. ಇದರೊಳಗೆ ಒಂದೇ ಒಂದು ಟ್ರಿಕ್ ಅದ. ಏನು ಟ್ರಿಕ್ ಅಂದ್ರೆ ಒಂದೇ ನೆನಪಿಟ್ಕೊಳ್ಳಿ. ಈಗ ಒಂದೇ ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ಇದು ಒಂದು ನೆನಪಿಟ್ಕೊಳ್ಳಿ. ಮುಗಿದು ಇದು ಒಂದು ನೆನಪಿಟ್ಕೊಂಡ್ರೆ ಇದರ ರಿವರ್ಸ್ ಇರ್ತದ. ಇದು ಒಂದು ನೆನಪಿಟ್ಕೊಂಡ್ರೆ ಇದು ರಿವರ್ಸ್ ಇರ್ತದೆ, ಇದು ರಿವರ್ಸ್ ಇರ್ತದೆ ಅಷ್ಟೇ. ಬಾಕಿ ಎಲ್ಲ ಈಗ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋದಿಲ್ಲ. ತಿಳಿದ ಇದೇನು ಈ ಜಸ್ಟ್ ಇದನ್ನು ನೋಡಿದ್ವಿ. ವಾಟ್ ಇಸ್ ದಿಸ್? This is not transfer characteristics. Transfer characteristics ನಾವು ಬರೀಬೇಕು. ಈಗ heading ಏನೈತಿ ಟ್ರಾನ್ಸ್ಫರ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಐತಿ ಬಟ್ ವಾಟ್ ಇಸ್ ದಿಸ್ ನಾ ಈ ಜಸ್ಟ್ ನಿಮಗೆ ಏನು ಹೇಳಿದೆ ಟ್ರಾನ್ಸ್ಫರ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಅಂದ್ರೆ V0 by V0 versus VI ಇದೇನೈತಿ I versus V ಐತಿ ಇದು this is for n MOSFET ನಾ ಈ ಜಸ್ಟ್ ಹೇಳಿದೆ ಫಸ್ಟ್ ಕ್ವಾಡ್ರೆಂಟ್ ಸೆಕೆಂಡ್ ಕ್ವಾಡ್ರೆಂಟ್ ಥರ್ಡ್ ಕ್ವಾಡ್ರೆಂಟ್ ಎರಡು ಯಾಕೆ ಬಿಡಿಸಿದೆ ಏನು ಯಾಕಂದ್ರೆ ಇನ್ವರ್ಟರ್ ಒಳಗೆ ಎರಡು ಅದಾವಲ್ಲ inverter the transfer characteristics ಬೇಕಲ್ಲ ನಮಗೆ therefore we require the transfer characteristics of inverter therefore I am just plotting VI characteristics of NMOS and VI characteristics of PMOS both are a part of inverter therefore I am plotting this ಎರಡು ಅದಾವಲ್ಲಿ ಅದಕ್ಕೆ ಎರಡು ಬರೆದಿಲ್ಲ ಓಕೆ ಈಗ ಏನು ಮಾಡಬೇಕು ಮಜಾ ಐತಿ ಏನು ಮಜಾ ಐತಿ ಇದನ್ನ take the mirror image ಇದರದ mirror image ಹಾಕಿ ಇದರದ mirror image ಅನ್ನು ಹಿಂಗೆ rotate ಮಾಡಬೇಕು ಓಕೆ ಹಾಗೆ rotate ಮಾಡಿ ಆ ಗ್ರಾಫ್ shift it or overlap that graph this mirror image of this graph in the first quadrant ಇಲ್ಲಿ ಹಿಂಗೆ ಇದರ ಮಿರರ್ ಇಮೇಜ್ ಹಿಂಗೆ ಆಗ್ತದೆ ಹೌದಾ ಇದನ್ನ ಓವರ್ಲ್ಯಾಪ್ ವಿತ್ ದಿಸ್ ಹಿಂಗೆ ಆಗ್ತದೆ from this graph again what is this graph IDSN IDSP mod ಹಾಕಿದ್ದೀನಿ mod ಹಾಕಿಲ್ಲ ಥರ್ಡ್ ಕ್ವಾಡ್ರೆಂಟ್ ಇಂದ ಫಸ್ಟ್ ಕ್ವಾಡ್ರೆಂಟ್ ಶಿಫ್ಟ್ ಮಾಡಿದ್ದಾರೆ ಅದೇ ಗ್ರಾಫ್ ನ ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಶಿಫ್ಟ್ ಮಾಡಿದ್ದಾರೆ ಸೊ therefore I have put mod on this ಯಾಕಂದ್ರೆ actually negative values ಇರ್ತಾವ ಅಲ್ಲಿ I am putting it in first quadrant therefore I am using mod okay so from this graph which I have got from mirror imaging and shifting or overlapping okay I will take the intersection points inverted. ಇದರೊಳಗ ಈ intersection points ತಗೊಂಡು ಹಿಂಗೆ ಪ್ಲಾಟ್ ಮಾಡಿ ಈ intersection points ಅಲ್ಲಿ ಕ್ಲಿಯರ್ ಕಾಣುತ್ತಿಲ್ಲ ಈ ಹಿಂಗೆ intersection points ತಗೊಂಡು ಹಿಂಗೆ ಪ್ಲಾಟ್ ಮಾಡಿ that graph which I get okay that graph will be my transfer characteristics or DC transfer characteristics of CMOS inverter ಇದು ನಮ್ಮ ಒರಿಜಿನಲ್ ಇದು ನಮಗೆ ಬೇಕು and what is this is current what this graph tells us very simple what this graph is telling us this graph is telling us this is V in V out inverter ಇದು okay so ಇಲ್ಲಿ ಬಂದ್ರೆ ಏನು ಕೊಡಿರಿ ಇದು ಏನು ಹೇಳ್ತದೆ ಅಂದ್ರೆ if V in is 0 V out is 1 ಅಂದ್ರೆ ಲಾಜಿಕ್ ಹೈ ಯಾಕಂದ್ರೆ ಇನ್ವರ್ಟರ್ ಅಲ್ಲ ಇನ್ಪುಟ್ 0 ಕೊಟ್ಟು ಔಟ್ಪುಟ್ 1 if V in is 1 V out is 0 this is VDD this is 0 input 0 is output 1 input is 1 2 3 4 5 input 5 volts ಕೊಟ್ಟರೆ output will become 0 okay but if input is 1 volt output is still 1 if input is 2 volts output is almost near 1 but slowly converge if input is 2.5 the output is falling down if input is 3 it has fallen down input is 4 it is 0 so this graph is telling us behavior of CMOS inverter for different values of input circuit ಹೆಂಗೆ ಬಿಹೇವ್ ಮಾಡತೈತಿ ಅದು ಹೇಳ್ತದ circuit ಹೆಂಗೆ ಬಿಹೇವ್ ಮಾಡ್ತೈತಿ how the circuit is behaving 0 ಇದ್ದಾಗ ಔಟ್ಪುಟ್ ಕ್ಲಿಯರ್ಲಿ 1. ಇನ್ಪುಟ್ ಅರ್ಧ ಮಾಡಿಬಿಟ್ಟಿರಿ, 2.5 ಬಿಟ್ಟಿರಿ, ಔಟ್ಪುಟ್ ಅರ್ಧ ಬಿದ್ದಿರ್ತದೆ. ಔಟ್ಪುಟ್ ಅರ್ಧ ಬಿದ್ದಿರ್ತದೆ. ಯಾಕಂದ್ರೆ we are moving towards 5 volts. Output should move towards 0 volts. Okay. And as I cross this 2.5, output will fall to 0. So this is falling down. So actually this graph is also divided in 5 regions. Region A, region B, region C, region D, region E. And the summary of individual MOSFET region A ಒಳಗೆ what is the condition? A condition is input is between near 0 or input is almost near to 0 or equal to 0 and below the threshold voltage. Region A ಅಂದ್ರೆ ಇದು region, ಇದು this is region A. ಇದು ಪೂರಾ region A. Input is near 0. Okay. What is output? Input near 0 ಅಂದ್ರೆ output VDD. Inverter. What is CMOS and PMOS behaving? This is in linear, this is in cutoff. ಇದಕ್ಕೆ ಬಂದೇ ಐತಿ. ಯಾಕೆ ಬಂದೈತಿ? ಇನ್ಪುಟ್ 0 ಕೊಟ್ರೆ CMOS ಇದೆ. CMOS ಇನ್ಪುಟ್ 0 ಇದೆ ಆಫ್. ಹೌದಾ ಇಲ್ಲ? So ಇದೇನೈತಲ್ಲ this entire table is depending on these conditions. Whether it is on or off, whether it is in linear region or cutoff region or saturation region, ಇದೆಲ್ಲ ಇದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತದೆ. ಇದೆಲ್ಲ ಹೇಗೆ ಕಂಡುಹಿಡಿಯಬೇಕು? ನಾನು ಜಸ್ಟ್ ನಿಮ್ಗೆ ಇದು ಹೇಳಿದ್ದಲ್ಲ, ಈಗ ಜಸ್ಟ್ ಇನ್ನೊಂದು ಟೇಬಲ್ ತೋರಿಸಿದ್ದೆ, ಆ ಟೇಬಲ್ ಯೂಸ್ ಮಾಡಿಕೊಂಡು we come to a conclusion that okay, if input is this much, PMOS is working in linear, NMOS is totally off, output is this. If input is little more than VT but less than half, input is little more than VT but less than half, ಇದು A region, this is A region. If input is little more than threshold voltage but less than half, ಇದು half ಇದೆ, it will be region B. Region C ಅಂದ್ರೆ if input is exactly VDD by 2, input is exactly VDD by 2. What is the output? Output is also VDD by 2. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ input half ಬಂದಿದ್ರೆ ಇದು ಬಿಲ್ಡಿಂಗ್ ಬಂದಿದೆ, that is also VDD by 2. Okay. So the region of working ಇದೆಲ್ಲ ನಿಮಗೆ ಹಳೆ ಟೇಬಲ್ ನಿಮಗೆ ಗೊತ್ತಾಗ್ತದೆ. ಹಳೆ ಟೇಬಲ್ ಈ ಟೇಬಲ್ ಮ್ಯಾಚ್ ಮಾಡೋದು. ಫೈನ್. ಲಾಸ್ಟ್ ಕೇಸ್ ಏನಿದೆ ನೋಡಿ, V greater than VDD by 2. Okay. But or input is almost near to VDD. Greater than VDD by 2 ಅಂದ್ರೆ greater than 2.5. Okay. So almost near to VDD. Output is 0. Input is near to 1. Output is 0. Input is near to 1. Therefore, PMOS is off. Okay. So this is all about DC transfer characteristics of CMOS inverter.